Like the United States, China has its sights set on establishing a permanent base on the moon within the coming years. While the Trump administration once stressed that America had to win the race back to the lunar surface before China, Beijing insists it's not racing anyone. And in many ways, that's true, because China already has a well-defined plan and is methodically executing it. So, what would a Chinese moon base actually look like? As the 21st century unfolds, the moon has once again become the centerpiece for the world's top spacefaring powers. NASA, for instance, is pushing forward with two massive efforts: the Lunar Gateway, often just called Gateway, and the Artemis program, both centered on exploring the moon's south pole. The plan is to have the Gateway Lunar Orbital Station in place before 2026, serving as a launch point for human missions, the setup of lunar outposts, and eventually as a springboard for journeys to Mars and beyond. Russia, too, has placed lunar exploration near the top of its agenda. It's deploying a series of unmanned probes, Luna 25, 26, 27, and 28, all targeting the moon's south pole, with the long-term goal of sending cosmonauts and building a lasting lunar base. Meanwhile, the European Space Agency has its own grand vision, including concepts like the Moon Village and the Heracles program, designed for cargo delivery and lander support for crewed missions. Japan, building on the success of its Kaguya mission back in 2007, has become a key partner in NASA's Artemis and Gateway programs, as well as Europe's Heracles initiative. Clearly, every major player wants a piece of the lunar frontier. And of course, China isn't staying on the sidelines. On March 9, 2021, China and Russia made headlines when they signed a memorandum of understanding to build the International Lunar Research Station, or ILRS, a joint venture focused on creating a permanent research base near the moon's south pole. That location is especially valuable because it's believed to contain deposits of water ice, a resource critical to sustaining human presence and producing fuel for deeper space missions. Even though China entered this modern space race later than others, history shows that when Beijing sets a goal, it tends to meet it, and often right on schedule. That's saying something in the world of space exploration, where delays are practically expected, especially for projects of this magnitude. According to China's official plans, the International Lunar Research Station is being developed under the principles of joint consultation, shared construction, and mutual benefit. Led by China in collaboration with global partners, it's envisioned as the first large-scale scientific platform operating both on the lunar surface and in orbit. At its core, the ILRS is meant to support a broad range of scientific, technological, and operational goals. It aims to pool the expertise and resources of multiple nations to study the moon, utilize its resources, and develop sustainable methods for exploration. That means the station isn't designed to serve one country or mission, but to be a shared hub where different technologies, objectives, and research priorities can work together. Building something this ambitious won't happen overnight. The ILRS will follow a modular, scalable design that allows it to expand gradually as new technologies and missions are added. Its construction will take a phased approach, with step-by-step launches, on-orbit assembly, and coordinated operation among participating countries. The plan includes both orbiting and surface elements, a cislunar transportation hub that will circle the moon to manage traffic between Earth and the lunar surface, and a long-term base for continuous human and robotic activity. Supporting infrastructure will include research labs, transport systems for crew and cargo, and mission control centers on Earth to oversee operations. The project will roll out in three main stages. The first, called the reconnaissance phase, runs from 2021 to around 2025 or 2026, and is already well underway. Although progress among partners varies, China has taken the lead here, achieving several major milestones. The Chang'e 4 mission made history as the first to land and operate on the far side of the moon, and Chang'e 6 in 2024 brought back the first ever samples from that region. Next up is Chang'e 7, scheduled for launch in 2026, which will focus specifically on the moon's south pole, one of the most scientifically rich and resource-laden areas. The second phase, known as the construction phase, will span roughly from 2026 to 2035, It begins with Chang'e 8 in 2028, a key mission that will test technologies for using local resources, like extracting oxygen or building materials directly from lunar soil to support future operations. This mission will also include payloads from international partners, signaling a shift toward broader global participation. Russia is expected to contribute during this period as well, with its Luna 28 mission likely taking place around 2030 or later. This decade-long construction phase is split into two parts. The first, from 2026 to 2030, will focus on validating new technologies and building basic capabilities, while the second, from 2031 to 2035, will focus on setting up core infrastructure. Between 2031 and 2035, 5 major ILRS missions, ILRS 1 through ILRS 5, are planned to establish systems for energy, communication, research, and human habitation. One of the biggest challenges facing the ILRS is power generation. And that's why China is seriously considering nuclear energy for the base. In fact, Roscosmos, Russia's space agency, revealed that it's working with China's National Space Administration to deploy a nuclear reactor on the lunar surface by 2035 to power the ILRS. The current plan calls for the reactor to be assembled on Earth, fully fueled with uranium and launched as a single integrated unit. To keep it safe during the journey, the control rods that regulate the fission process would remain fully inserted, keeping the reactor subcritical and inert. Once safely landed on the Moon, the system could be activated either remotely or by astronauts on site. Of course, the idea of launching a nuclear reactor into space sounds alarming to many, but in practice, it's far safer than most imagine. Fresh uranium fuel is not highly radioactive, unlike spent fuel, and poses little radiological risk before operation. Even in the unlikely event of a launch failure, the material would not create serious danger to people on Earth. The final phase of the plan, called the utilization phase, will begin around 2036 and extend well into the future. By then, the ILRS is expected to become a fully operational and expandable lunar base, supporting long-term scientific research, technology testing, and potentially even a permanent human presence. Having this base will position China as a major driver of innovation in lunar technology and strengthen its influence across multiple domains. Scientifically, the ILRS will lead studies in geology, resource exploration, and space environments, unlocking answers about the Moon's history and paving the way for deeper space missions. First and foremost, the ILRS will advance science and technology. Research on lunar topography will focus on understanding how the Moon formed and evolved geologically, through studies of basalts, tectonic scarps, and underground lava tubes. High-resolution imaging and return samples will help determine how long volcanic activity lasted, reveal internal stress patterns, and locate lava tunnels that could one day serve as natural shelters or resource hubs for future explorers. Exploration of the Moon's internal structure, a goal that dates back to Apollo's seismic experiments, will aim to settle long-standing questions about crust thickness and core size. China's upcoming seismic network, part of the Chang'e program, will provide precise data that could finally reveal how the Moon's inner layers are arranged and how they behave during moonquakes. Another key focus will be the study of lunar water and volatile elements. Evidence from returned samples shows that water exists both beneath the surface and at the poles, suggesting it may have been present since the Moon's earliest days. Future missions will map how much water and volatile matter is actually there, helping scientists understand their role in lunar evolution and their potential use for sustaining life and generating fuel. Research into the Moon's chemical composition will also continue. Samples from Chang'e 5 have already refined theories about the Moon's magma ocean and interior evolution. Upcoming missions will collect more diverse rocks, including ancient crustal material and young volcanic basalts, to pinpoint the timing of major lunar events, explain volcanic processes, and clarify the Moon's impact history. Studies of the Moon's magnetic field have shown that it once had a liquid metal core that generated a magnetic dynamo, recording the Moon's internal evolution over time. Future orbital and surface missions will map magnetic anomalies in greater detail improving our understanding of how that ancient dynamo worked and how these magnetic regions still interact with the solar wind today. The Sun-Moon environment offers a perfect laboratory for studying plasma interactions and space weather. Because the Moon has no thick atmosphere or global magnetic shield, its surface is constantly bombarded by solar and cosmic radiation. This affects both the lunar soil and any equipment or humans stationed there. Research in this area will focus on radiation hazards, dust charging, and how particles interact with the surface. All critical factors in understanding space weather, radiation shielding, and the creation of lunar water molecules through surface chemistry. Lunar-based astronomy is another exciting field that benefits from the Moon's stability and radio silence. The far side of the Moon, shielded from Earth's electromagnetic noise, provides a pristine location to study the early universe. Future telescopes placed there could detect faint radio signals from the cosmic dark ages just after the Big Bang. Tracking the Moon's motion with extreme precision would also help refine celestial reference frames and improve our understanding of both lunar and Earth dynamics. From the Moon, scientists could continuously observe Earth as a whole, something satellites can't do as easily due to their limited coverage. A lunar observation platform could provide long-term monitoring of Earth's atmosphere, oceans, and land, offering valuable data about climate patterns, energy balance, and environmental changes over time. Life science research will also be critical for survival on the Moon and beyond. Experiments will study how plants grow, microbes behave, and ecosystems function under lunar gravity, radiation, and soil conditions. These findings will help build bioregenerative systems for food, water, and oxygen, essential for long-term habitation and future missions to Mars. As mentioned earlier, the International Lunar Research Station is not meant to be just a Chinese or Russian project. It's designed as a truly international effort. By 2025, China had already signed on several partner nations, including Venezuela, South Africa, Azerbaijan, and Thailand. At the 2022 International Astronautical Congress, China introduced a 5-tier participation model to ensure that both national and commercial partners could play meaningful roles, beginning with the Chang'e 7 mission. This framework allows different countries and organizations to join at varying levels, whether by contributing instruments, technology, research, or logistics support. This inclusive strategy is already influencing China's recent and upcoming lunar missions. Chang'e 6, for example, did much more than return samples from the far side. It also carried scientific instruments from France, Sweden, and Italy, as well as a small CubeSat built in Pakistan. Although the United Arab Emirates had to withdraw its Rashid 2 rover from Chang'e 7 due to export restrictions, the mission will still continue the pattern of multinational collaboration. Looking ahead to Chang'e 8 in 2028, China has already received over 30 proposals from international partners vying for its 200 kilograms of available payload capacity, showing just how much global interest the ILRS has generated. By opening its doors to a broad mix of nations and organizations, China is positioning the ILRS as much more than a moon base. It's presenting it as a global alternative, an open, cooperative platform that contrasts sharply with Western-led efforts like Artemis. In doing so, China is extending its soft power and establishing itself as a leader in the next era of lunar exploration. Even though China's lunar program began later than others, it started at a remarkably high technical level and has rapidly advanced to rank among the world's leaders in several key fields. NASA, by contrast, is pursuing highly ambitious goals, which has also contributed to delays in its own program. In the end, while the United States often frames lunar return as a race, China views it as a steady climb. Whoever touches down first at the moon's south pole will achieve something historic. But ultimately, both nations' progress will expand humanity's reach beyond Earth and benefit us all.